Everyone, so today we have 5 questions to elaborate. So, Mock 1, question 4 BC, Mock 2, question 4 BC, and question 5A. This is Zhou Yingzhou, and we will do the Mock 1 question 4B. So the question says that the internal auditor of a large company are interested in the system by which incoming invoices are processed. They take a random sample of 50 completing invoices and check them in detail for correctness of procedure for a fund to be defective in some ways. And after they adjusted to the new procedures, auditors take a random sample of 60 completed invoices, and this time they found that 3 incorrect ones. So the question asks that is there any evidence at 5% level of significance that the new procedure has improved the error rate? So let's look at the solution here. Let P1 be the proportion of the defective before the new procedure, and let P2 be the proportion of the defective after the new procedure. So N1 we have the 50 and N2 we know that is 60. So the P1 is 4 divided by 50 is 0.08, and also we have P2 like this 0.05. And also we have the P head, which is 0.0636. So since N1 is greater than 30 and N2 is greater than 30 as well, so we can use the z-test, and we have the hypothesis. So the null hypothesis is P1 minus P2 equals to 0, and H1 is that P1 minus P2 greater than 0. So at 5% of significance, so we have alpha equals to 0.05. So the critical region is z bigger than 1.645. So based on the testing difference of two proportions, we can use the formula here. So we have the P1 is 0.08, N1 is 50, and P2 is 0.05. N2 is 60, and P head is the overall proportion is 0.0636. So we have that, which basis on the which formula here we have the z is 0.6418, so it's less than 1.645. So we do not reject H0, which stands for that the newest procedure didn't improve the error rate. So that's all. Thank you, everyone.
Hi guys, I'm Lian Xiang. Then let me show you how to solve the problem in Mock 1 question 4 part C. First, let's look at the question. A health spa has advertised a weight-reducing program. A somewhat overweight executive is interested in the program, but is skeptical about whether the program can help participants to reduce an average of more than 17 pounds. The spa allows him to select randomly the records of 10 participants and record their weights before and after the program. These data are given in the following table. So the question is, assuming normal populations, is there any evidence to suggest that the program can reduce, on average, weight of more than 17 pounds at 5% level of significance? Drawn from the question description, we know that there are 10 participants in the sample, and their weights before the program are 189, 202, 220, 207, 194, 177, 193, 202, 208, 233. Their weights after the program are 170, 179, 203, 192, 172, 161, 174, 187, 186, and 204. We can easily note that it is a paired sample test since we collect data from the same group of participants for both mu1 and mu2. Then we can compute the difference between the mu1 and mu2, which are 19, 23, 17, 15, 22, 16, 19, 15, 22, and 29. For later use, we also calculate the sample mean, bar D equals to 19.7, and the sample standard deviation equals to 4.3982. To solve this question, the first step is to formulate the null hypothesis. D0 equals to 17, which means mu1 minus mu2 equals to 17. And then we formulate the alternative hypothesis, D0 larger than 17, which means mu1 minus mu2 larger than 17. As we can know from the question description, the level of significance is equal to 0.05. It should be a one-tailed test since we only care about the right direction. Then we want to draw a curve, and the bar D is used. So is bar D normal or not? Yes, it should be normal because the population is normal. So the curve can be drawn like this, and the middle point should be the mean of the bar D. Since the variance of D is unknown and the sample size is small, smaller than 30, so we use the t-table, and the degree of freedom should be the sample size minus 1, which equals to 9. We check the t-table and find out that this point should be 1.833. So the critical region should be t larger than 1.833. Then it's time to do the test statistic. Since it is a paired sample test, so we use this formula, t equals to bar D minus D0 over SD divided by the square root of n. Then we generate the result, which is 1.9413. Since it is larger than 1.833, so we can reject the null hypothesis and conclude that D0 should be larger than 17.
Good day everyone, my name is Sapphire and I'm going to introduce Mock 2 question 4b to you. PM Group is considering opening a restaurant in a new district, and the group decides to carry out a research to make sure that the restaurants will make profits. Average family income of residents in the district is believed to be a good indicator of profitability, and a level of $18,000 at least is required. The group then takes a random sample of 64 households in the district and finds an average monthly income of $17,100 and a standard deviation of $1,200. At a 0.01 level of significance, test whether the group should open the restaurants in the new district. Now let's move with the average family income of the new district. So we can have two hypotheses here, which is milk greater than 18,000 or equals to $18,000, and H1 being milk smaller than $18,000, with alpha being the level of significance which is 0.01. Since the sampling size is 64, which is greater than 30, so by the central limits theorem, the sampling distribution of mean is approximately normal and a z-test should be used. Also, we should use a one-tail test. By the z-test, we can identify the critical region to be set less than negative 2.33, and here is the formula used for the test statistic. Z equals to 17,000 and $100 minus $18,000 divided by $1,200 divided by the square root of 64 equals to -6. Since -6 is smaller than -2.33, it is in the critical region and H0 is rejected. Therefore, the hypothesis that mu is greater than or equal to $18,000 is rejected at 0.01 level of significance. As a conclusion, the group should not open the restaurants in the new district. Thank you for listening to my presentation.
Hello everyone, my name is Tia Xue. Today I'm going to solve the question Mock 2 Q4C. Let's look at the question first. A marketing researcher is comparing the characteristics of buyers and non-buyers of a particular product. Independent samples of buyers and non-buyers are selected, and the age of respondents are listed below. The question asks us to test whether there is a difference between the mean age of buyers and non-buyers at 5% level of significance. First, we let x1 and x2 be the age of buyers and non-buyers respectively, and we assume that both data are normally distributed. According to the sample table showed above, we can calculate the sample mean and sample standard deviation according to these two formulas. We get mu1 is equal to 39.8 years old and mu2 is 47.2 years old. As for sample standard deviation, S1 is 10.04 years old and S2 is 13.62 years old. The next step is to identify the hypothesis. The null hypothesis is mu1 minus mu2 is equal to 0, which means mu1 is equal to 0. And the alternative hypothesis is mu1 is not equal to 0. We can know from the question that the levels of significance is 0.05. We know that the sample size of buyers and non-buyers are 20, and we don't know the sigma 1 and sigma 2. But the sum of the sample size is 20 plus 20, which is 40, is larger than 30. So we will use the table. It's a two-tailed test, so we divide alpha by 2 and get 0.025. We find this value in this t-table and get 1.96. So we get our critical region, which is E is less than -1.96 or is larger than 1.96. And it's shown in this graph. We assume that sigma 1 is equal to sigma 2, but we don't know the value of them, so we can use this formula. We know that T0 is equal to 0. We know the mean of buyers and non-buyers, and the sample size and the sample standard deviation. So we can calculate SP and get 11.9653, and then we calculate T and get the T value, which is -1.95573. Look at this graph. The T value is larger than -1.96 in this Y part. So we can draw our conclusion. We do not reject H0 null hypothesis and conclude that mu1 is equal to mu2.
Mock Paper 5, Question A. A management training program is organized by a company to teach supervisory skills. The participants attempted the examination before and after the training program, with higher scores representing better supervisory skills. A random sample of 10 supervisors is selected, and their examination scores are as follows. So the table presents the number of the supervisors, the scores before the test, the scores after the test, and the difference in between. So the question is to test whether the management training program is effective in improving supervisory skills at 5% significance level. State the assumptions. So the solution is that if we denote the mu1 as the mean score of the supervisors before the test and mu2 as the mean score of the supervisors after the test, we set the null hypothesis as the mu1 is equal to the mu2. And as the question has already indicated that we have to test whether the program was effective in improving supervisory skills, it's going to be the one-tailed test. So the alternative hypothesis is that mu1 is less than mu2. So the significance level is 5% and the degree of freedom is 9. So our critical region is that the t will be higher than 1.833. The reason why we use the t is that we assume that the mean of the differences follows the normal distribution and the sample size is less than 30. So at the degree of freedom at 9 and significance level at 5%, the t should be higher than 1.833. So the mean of the differences is 69 over 10, which is 6.9, and the standard deviation is 5.4253. So we implement the test statistics and we use the formula given, and we find that the t is equal to 4.0219, which is well in the region of higher than 1.833. So we reject the null hypothesis and conclude that the management program is effective in improving supervisory skills at 5% significance level. Thank you.